So to the nearest centimetre, A is 4 cm, B is 8 cm. Calculate the smallest possible length of the following. A plus B. So the lower bound of A, which is 3.5, and the lower bound of B, which is 7.5, gets the answer 11. That's the smallest possible length if we add them together. Timesing is exactly the same. We both use the lower bounds. So it'd be 3.5 times 7.5, which is 26.25 centimetres. Now, that makes sense, doesn't it? To find the smallest possible, we use the lower bound and the lower bound of everything to find when we're adding in times. But subtracting and dividing is slightly different. When we're subtracting, to find the smallest possible value or length, it's the lower bound minus the upper bound. This will give you the smallest possible value. So, the lowest bound of B, okay, is 7.5. I'm going to take the upper bound of A, which is 4.5. Alright, which is 3 centimetres. And it's very similar for dividing. To find the smallest possible, okay, it's the lower bound divided by the upper bound. So the lower bound of B, which is 7.5, and the upper bound of A, which is 4.5. So 7.5 divided by 4.5 is 1.6 recurring. Okay, so adding and timesing are quite straightforward, but subtracting and dividing are the ones you have to be careful with. So for this question, I'm just going to concentrate on subtracting and dividing as they are the most confusing. Adding and timesing is straightforward. For the maximum possible for adding and timesing, you just find the upper bound of both values and add or subtract them. So if we're doing B take away A, okay, and we'll find the maximum, we would need the upper bound take away the lower bound. So the upper bound of B, which is 8.5, take away the lower bound of A, which is 3.5, gets you the answer of 5. So very similar for dividing. B divided by A, to find the maximum, okay, would be upper bound divided by lower bound. So that would be 8.5 divided by 3.5, which would give you the value of 2.4 if you round it correctly. So, very similar question, obviously just looks different. John runs 200 metres to the nearest metre in 25 seconds to the nearest second. What is his fastest possible speed? So to find the biggest speed. So that's the maximum speed we could do. Reminder, how do you find speed? Well, it's speed equals distance over time. So we are going to be doing distance divided by time. So on the fastest speed, we need to do the upper bound divided by the lower bound. Okay, because that will give you the maximum speed it could possibly reach. So it was the upper bound of the distance. So John runs 200 metres to the nearest metre. So the upper bound for that would be 200.5 divided by the time, 25 seconds to the nearest second. So the lower bound for time, which would be 24.5. Grab your calculator, enter it as 200.5 divided by 24.5 gets you the answer of 8.18 meters per second. Okay, and obviously you have to round it carefully. Again, for the slowest possible speed, we are going to be doing distance divided by time, but because we're looking for the slowest, it's now the lower bound, swap them round, divided by the upper bound. So it's going to be the lower bound of 200, which to the nearest metre, which is 199.5, divided by the upper bound of the time, which is going to be 25.5, which is going to get you the answer. Type it into your calculator, 199.5 divided by 25.5. It gives you the answer of 7.82 meters per second. Okay?